uncertainty budget that one might have. So as I described yesterday, there are limits in the validity of the LPU method. Um, so in order to overcome these limits, we use the Monte Carlo method. This is why it was actually devised to be used in metrology. It's used in other areas of physics also, and chemistry. Um, but we are only going to look at a very limited application of it. And I said that the software that I wanted to show you is the NIST uncertainty machine because of its simplicity and its ready availability. And it's very easy to operate and have a, let's say, independent appraisal of what your uncertainty budget might be in a particular situation. So it's written in a statistical language called R, okay? And it does both propagation of uncertainty and the Monte Carlo method. So you can compare in real time um, between how well your model stands up to the requirements of the law of propagation of uncertainty. The basic requirement being that what happened here? I didn't do anything. Huh? It's kind of slow. Oh my God. Okay, so as I was saying, um, I showed you a little bit. Well, I showed you actually the whole interface, the input interface and the output interface of the uncertainty machine. And I'll just go over it briefly today, and then you can play around with it, and we'll do the example that we did on the first day, which was the density of a solid by immersion in a liquid of known density, okay? And see how well the how well you did the derivatives, and if the the model not being exactly linear, if that affects in any way the validity of the use of the law of propagation of uncertainties. So the interface looks something like this, where you can input basically, um, it's very simple to operate. You input the quantities, Then you have to decide what type of distributions, probability distribution functions you're going to assign to them. And then you have to choose how many trials the Monte Carlo engine will actually go through. And in order for the either propagation of uncertainty or the simulation to occur, you need a model. So the next thing and the last thing you have to do is you have to input your model, and that's done in the last box down at the bottom left. And once you do that, then you run the simulation, and the output screen looks something like this, where on the left you have the statistics of both the MCM and of LPU. So MCM gives you the average of the number of trials, the standard deviation, the median. It gives you a coverage interval. Actually, it gives you many coverage intervals depending on the coverage probability that you might desire. It tells you which component is the most contributing, the dominant component in the uncertainty. And at the bottom, it also does the mainstream GUM or LPU or whatever you want to call it. It computes the value of the output estimate, the uncertainty of this value, and the sensitivity coefficients that were used. And again, the percentage contribution of each component of uncertainty to the total uncertainty. On the right-hand side, you have a graph which shows you how well, I mean, it shows you very quickly how well LPU or how good of an approximation LPU is in the current situation. So it compares the Monte Carlo output probability density function with Gaussian or t-student probability function as calculated from the regular mainstream GUM. Now, it also gives you the possibility to download the data and download the input configuration, so the data that you input, as well as the output screen. So you can download it as a text file, and you can use it in Excel or whatever you might want to use it. So this was the example. We wanted to determine the density of a solid. This density is rho. And we want to do this by measuring its buoyancy. With this. Okay. All right, so if I can find the thing. So this is the density of the solid that we're looking for. This is the density of the liquid at a particular reference temperature. In this particular case, it's 20 degrees. Gamma sub V is the expansion coefficient of the liquid. T is the temperature. And WLA is a ratio of the weighing results that one got when he weighed the object in the liquid and weighed it in air. Okay? So this is a number. It doesn't have units, in other words. So the data involved here, there are four input quantities. The estimates are given, as well as the uncertainty intervals. You have to remember or rethink what the distributions were, assign the distributions correctly in the uncertainty machine, and then just let the program do the hard work. So again, in order for you to reach the NIST site where this uncertainty machine is. It's the site uncertainty.nist.gov. And you should get the screen. So you have to assign the number of quantities. What? So out of curiosity, what would happen if you increased or decreased the number of trials? You want to do it one more time? Once with 1/10 of the trials instead of 1,100,000. And with, I don't know, I think 5 million is the maximum that it allows. And with 5 million trials, will something change? Hmm? I don't think that the value will change, but I presume that the number of significant digits will change. So try it. Let's see with 100,000 first of all. I mean, this is a nice experiment to see what happens. Someone can do 1,000, 10,000. These are numbers which are handled by Excel, but 10,000 is the maximum. And then you can try to do 100,000, which starts to become a real Monte Carlo. The 1 million you did, and then you can increase that to, I don't know, 4 or 5 million trials, which would be an extra accurate, let's say, Monte Carlo simulation. Can't hear you. 10,000 then. Okay, so start from 10,000. So if you finished the first trial with the 1 million Monte Carlo iterations, then download, save the configuration file on your computer, okay? Clear the input screen and do that drag and drop thing so you can see that, in fact, if you just take the configuration file and you put it into the box that it shows, then the data automatically is recovered. By how much? I can't hear you, Asma. If you want to speak, please use a microphone. I can't hear you. 200. Yeah. Okay. Mm-hmm. And what if it's 5 million? So it's taking more time, you see. Same. Yeah. What about the value? 4372.9, is it? 0.3. What was it with the other? Well, all of them. So this has less digits. has even less digits. Okay, so the number of trials determines how many significant digits you have. And it affects the uncertainty, of course, because um, the uncertainty comes from a standard deviation, really. And the more numbers that you have in the standard deviation, the better the uncertainty is. Two microphones, please.
Check if we did it right, Doctor. So we are inserting here the limits
Okay.
like this. What about the value, the actual value? This one.
Which one?
This one. Should we enter it also?
Well, you.
We use this.
It depends on how you enter the probability distribution.
Okay.
So you can enter the probability distribution as endpoints, rectangular with endpoints, or you
Okay.
can enter it rectangular with a mean and a standard deviation.
So the mean and the standard deviation from this example, we have the mean, but not the standard deviation.
Yeah,
is it?
so it's the typical way that we are used to entering these types of distributions is with endpoints.
Okay. And it's not a correlation, is it, Doctor?
No. Now the seed there, I would put 0.
Here, 0?
Yeah.
Random
Symmetrical,
number
why did you put
generated
symmetrical
seeds.
coverage intervals?
I just thought it's like a Gaussian. So we
Yeah,
want
but
to
let's
keep it
see
the center.
without forcing it to do
Okay.
symmetrical, because now you're forcing it to do something here. Let's see what it gives you just by itself.
Error.
Output expression doesn't.
Oh,
Is it this?
so the formula is probably not correct.
Ah, we have to enter the formula here.
Yes.
Okay. Okay, we'll do.
So you have to use the variables that you defined,
Yes.
the actual names of the variables, to use them in a mathematical expression there.
Thank you
Okay?
so much.
Okay. That is more reasonable than what I saw previously.
The question?
Mhm. No, just the right hand side. No equal, no. So you forced it to do symmetric intervals. Show me how. Okay, go further down. Okay, what if the seed becomes 0? Make the seed 0. The generator seed. Yeah. T0 is 20. It's 20 degrees. It's the reference temperature. Yes. So what did you get? Let me see the graphs. Okay. You did something strange here because it's not the, that's why I was a little bit confused. It's not the output that I'm getting. I don't know what you did exactly. Yeah. Well, for the uncertainty, for the probability distribution. I don't know what you did. Maybe the input you did something. Let me see. Yeah, you use the mean and standard deviation, rectangular. So what's the mean and what's the standard deviation? How do you calculate these? Yeah.
Because we take the number.
Don't find shortcuts, okay? We usually do it by putting endpoints. So put the endpoints. Put the endpoints of the rectangular distribution. Because here you have to do calculations now to find the mean and the standard deviation. If you hadn't done it before, then you would have to do the calculations. Whereas,
Rectangular,
yeah,
left endpoint and right endpoint.
that's right. Not there, for the, yes, not for the first one. The first one is, I think, anyway. No, the first one is also rectangular, isn't it? All of them are rectangular. So use left and right endpoints. You'll be surprised that you're going to get a different result. And I don't know how you did the calculation of the mean and the standard deviation. I don't know what you entered in there. Well, if the two numbers that you haven't put are not equivalent. You think that they're equivalent, but they're not because I don't know why. You have to look at it. The simplest thing to do is just put the endpoints. Well, you're getting a distribution which is better than the actual distribution of this example. Okay, the actual distribution resembles more of a rectangular shape than a Gaussian. The endpoints are the plus or minus limits that you have, the interval.
We have the
You do, you have plus or minus 50. So you take minus 50, but be careful with the units, huh? No, but you have to be consistent. So if you put the mean and the standard deviation, you should have put 0 for the value, and the standard deviation should have been 50 divided by the square root of 3. I think probably the mean value is what you didn't put in correctly. Hmm? The difference is that there's a bias introduced if it's not 0. So I think they put a number in there. And where did it come from? I don't know. How did they calculate it? So as long as you're consistent, any way you enter your data is okay, but you have to be consistent and correct. Wow, this is more of a, you overdid the rectangular here. Yeah, but how did you enter it? Let's see. Let's see what you input. So there should be 3 rectangular, right? Is that how we did the example here? Okay, all right. Okay. That's the calibration certificate then, right? For the temperature, it's from the calibration certificate. Yeah. What's that? Minus 0.2. So it's not an interval, okay, because you've entered it as an interval now. So you need a mean value, which is 0, because your errors are between minus 0.2 and plus 0.2, so the average is 0. And the standard deviation will be 0.2 divided by 2, which is the standard uncertainty gotten from the calibration certificate. Yeah, okay, play around with it, play around. Divided by 1. Again, you have an interval there, but that interval now is a standard deviation, right? That's a standard deviation. And no, it's already divided by the square root of 6. So it's the final standard deviation. And the mean is 0 because this is a non-biased, we're assuming it's a non-biased measurement. Okay?
We have Gaussian standard deviation, and this one I put in.
I don't know what truncated means. We have to open the manual and see what it means. That's too much of a rectangular now.
Last one, I keep it
Let me
in
see,
standard deviation.
First one is minus 50, 50. The second one is, okay. Third one is normal though, isn't it? We did, this was a normal distribution when we did this because it's from a calibration certificate. Yeah. I think so. Let's see, what else do you offered?
You have this one, that one.
That's it.
I have
Standard deviation. Which
this
one?
one.
Yeah, the truncated, I'm not sure what is meant by truncated. I think the truncated means that it doesn't go all the way out to minus infinity and plus infinity, but it's truncated somewhere. So it's a little bit different. Yeah, yeah. Yes. Minus 0.2 from the certificate?
No correction.
Right, so there's no correction. So 0. Yeah. That's the expanded uncertainty because it's 95%. Yeah. Yeah.
What about the type A?
Yeah, this is a weighing, so it's a Gaussian. And you have a standard deviation, which is 0.005. Again, it's considered to be unbiased. Yeah. Yeah. The standard deviation.
The uncertainty, not what we calculate yesterday.
That's
Then when
right.
we calculate it,
So something is wrong. Did you check your formula?
formula is right. I'm pretty sure.
Is it calculated at 20?
Uh,
You know you can define that 20 as a constant. Yeah, but you can define it as a variable, but as a parameter. Because it's too much of a rectangular. I don't know why it's so rectangular.
because it will not affect the uncertainty. Not parameter.
No, it's not. It will not be taken into account in the uncertainty budget, but it will be definitely taken into account in the calculation.
I can put two equations.
No, you define it as where you define your variables. Put 5 now. Put 5 quantities.
So each line have parameters of answer.
Yeah, but now this is not a parameter. This is not a.
Can I put it?
It's a constant. And put in 20.
I define it.
Oh, it's T0, but the value is 20. Don't be in a hurry. Why are you in a hurry? Why? You're going to be here all day anyway.
Now like this, so I put this.
Yes. It's a little bit more rectangular than what it should be. I don't understand why. We can check to see what I did. Maybe mine is wrong. I don't know. But I saw someone else. I saw the doctor there. He got the same result that I did. So his distribution looked like the one that I have. Yeah. Yeah, play around. Hmm. Yes. I just want to say that for 17025, when your assessor comes and he asks you, have you validated your uncertainty budget? Okay, you can use this to prove that it has been validated. Because this software has been validated many times. All the certificates are on the website. So the assessor can go and look and see, what the situation is. But this is a safe way of getting around that. Yeah, that's good. How's it going, gentlemen? Got something out there. His output. It kind of looks too much of a rectangular. I don't know why exactly. Maybe you made some mistake in the input of the quantities. Let's see what you did here. So because the distributions of the input variables, the probability distributions of the input variables do not have a zero mean, okay? Why don't they have a zero mean? Because they have values associated with them. So you cannot enter the rectangular distribution as a left and a right endpoint. I mean, you can, but you'll get this nonsense result because the value is not going into the formula, so the actual calculation can be done. Okay, in the case where the average value of the input variable is 0, then there's no problem. But in the case that the average value is not 0, as in this case, because you have a value for the density of the liquid, it's 998. So then you have to add it, you have to input it as a rectangular distribution through a mean and a standard deviation. So the mean is the value that is given for the density, and the standard deviation is 50 divided by the square root of 3. The same is true for the alpha, I say here, the gamma variable, the expansion coefficient. For temperature, it's the measurement, which was 25.1, and the uncertainty is half of the uncertainty of the calibration certificate. Yeah, yeah. So to distinguish the well, it was including 0 values into the formula, and you were getting 0 as a result. You probably will have to say that you have to include it as plus 998. So it's RL sub 0 plus 998. So you have to do a trick of that sort. So just to summarize it now, the rule is if you have a distribution whose average turns out to be 0, so symmetric intervals, and you have no reason to believe that there's something different than 0 for the mean, then you use left and right endpoints. However, if you want to assign a rectangular distribution to an actual measurement, okay, to an actual number, then you have to use the rectangular with a mean and a standard deviation. Notice that WLA I've entered, it has 3 parameters. Because I've entered it as a student T, because 6 repeats are not necessarily normal. So when you do that, it asks you to also include the number of degrees of freedom, which are 5 in this case. And I've also entered the constant value as a parameter. And this is the formula that I use. I think you use the same thing. But the question is, the idea is to use the distribution correctly. Sorry about that confusion, but I think that playing around with it, it helped you a little bit. So you probably had the question, as I did, when I first saw this, why it has a rectangular distribution with endpoints and why it has one with a mean and a standard deviation. Well, this is why. Because there are situations where the average of the value to which I want to assign a rectangular distribution is not 0. So let me try running this and see what happens. Right, so this is what So the fact that it's not quite that Gaussian might be because of the t-student distribution that I've included, because that's a pretty big part of the uncertainty contribution. See, the uncertainty contribution is basically due to the density, 63%, and about 36% is the repeatability, the actual measurement of the weights. I think that the sensitivity coefficients, that was the most, let's say, promising to me, that the sensitivity coefficients are calculated correctly, by the way. So up to two significant figures, they're correct. So please put in the numbers so you can do it once, running it with the correct distributions. So you can have it on your computer. You can have the configuration. So has everybody finished? Have you done it? Yes? Okay, should we continue on? You want to do another example? So remember, this is important. I want to stress it. Otherwise, you're not going to get correct results with this thing. Is that there are quantities which have an expectation of 0. So there are errors with an expectation of 0. What are such errors? Can you tell me one such error? So the most typical such error is the resolution. The resolution contributes to the uncertainty, but it doesn't uh, um, present a correction that has to be made. So there's no correction that we make because of limited resolution. However, we do include it in our uncertainty budget. So the expectation in this case is 0. So errors whose expectation is 0 are entered with left and right endpoints, rectangular distribution. On the other hand, there are errors which are associated with an actual number. Okay? So in this case, since we want to put in this actual number, we have to input it using the mean and the standard deviation um, as a rectangular um, distribution. So in one case, I don't need to do anything when I have left and right endpoints. In the other case, I have a number which I have to input as the mean, and I have to calculate the standard deviation, which would be the half interval divided by the square root of 3. Obviously, the same is true for triangular, okay? Yes. If you wanted to put the error for the resolution that way, then the standard deviation would be half of the digit divided by the square root of 3. So you would have to calculate it and then enter it into the software. Okay, so today we'll switch gears a little bit and move away from uncertainty per se, but we're going to be discussing interlaboratory comparisons and um, some requirements with regard to organizing, analyzing, reporting, and linking in the case where we're talking about linking an RMO comparison to a CC key comparison. So the linking is a topic of research interest. I'll present one method that's used. So it depends on what the specifics are and what the circumstances and how many participants there are and how many linking laboratories. All of these play a role into which methodology someone will follow. But before we go into that, I'll talk a little bit about the planning and the reporting. Then I'll talk a lot about the selection of the artifact and the monitoring of the stability of the transfer standard, which is very, very important if someone wants to analyze the results. Then I'll show two methods of calculating a reference value. or what is called in terms of proficiency testing an assigned value. And then I'll show you the method that is used predominantly, even today, for linking comparison results based on the degrees of equivalence and on their uncertainty. Okay. So the most important aspect, which is many times overlooked with ILCs and their organization and their execution, is the technical protocol. So an ILC has to have a definite technical protocol which describes all of the details that someone has to pay attention to when they're doing the measurements and when they're shipping the object, the artifact, the transfer standard from participant to participant, and in terms of following the schedule. So why do you think it's so important that everyone follows a technical protocol, which prescribes what has to be done? Yeah, you're right. You want. Mhm. Yeah. So the basic idea, the basic concept behind a ILC, a comparison, okay, is that everybody's measuring the same thing. So, and everyone has to make a decision with regard to whether this same thing represents the same physical quantity. Okay, so if there are changes of the artifact, or there are changes in the environment, or there are changes in the stability or anything of that sort, there's extra variability, then it cannot be guaranteed that everyone is actually measuring the same item, thus the same quantity, because this item represents a specific quantity. Okay? By the way, do you know what the difference between a PT is and an ILC? Who can, who has an idea of what the difference between the two might be? They're almost the same. You remember? Yeah. Okay. So, okay, it's a fine line. The distinction is a fine line. It's not that evident. But the thing is that in a PT, which is very, very relevant to testing, really, okay, and this is something that should be made evident to the accreditation bodies in the region. To PT, there is a decision at the end of pass or fail. So it's a conformity assessment type of a activity. Okay. So the participant is judged to pass or fail based on his satisfactory or not participation in the well, no, in a comparison, there's no judgment. It doesn't say pass or fail. So a PT uses an ILC, a comparison, in order to judge the performance of the participant. An ILC does not judge the performance. It depends. It depends. I mean, we're not I haven't gone into the details yet. So, but there's a distinction between the two, okay? A PT is something which the end result is pass or fail, and the decision is based on the results of an ILC, whereas an ILC has no pass or fail component associated with it. Okay, it's a comparison. It's a comparison with respect to typically for high-level uh, laboratories, it's a comparison with the average of all of the participants. So it's based on consensus, typically. But it doesn't have to be that way. But usually it is.
Participate as common as laboratory secondary level or working standard. They would like to have to prove their capability for accreditation reason. Also, it's as you said, there is pass and fail, and it will be done by four ways, like reference lab, reference lab, expert laboratory, and the common way is the reference lab. As we see in some countries, and PT provider is done by the reference lab. And there is for pass and fail, there is there is a limitation for the number of participants. If their result is out of the range, they have to repeat the whole PT. As written in the 17,043, 43. 43.
Mm-hmm. Yeah. Yeah.
Situation. we have a complicated situation for the subcontractor. At NMCC right now, we are providing BT, okay, and we are using reference lab from NMCC, and this is conflicting if we are the same provider who using the same lab. It should be for the separate, and but the problem is using the same quality system. What we have done in this situation, we have implement our quality system with writing some change in the procedure to be make sure the quality system is separate from the BT provider.
Okay. What I want to stress is that even though we use the words interchangeably, PT and ILC are not exactly the same thing. There's a fine line between them. And the fine line is that a PT scheme is something which is periodic, usually, so it repeats itself every year or every 3 months, depending on what the area is, okay? And there's an assessment of the participants' performance. Whereas in an ILC, there's no assessment of the performance. It's not periodic typically. I mean, okay, it's relatively periodic, but there's no assessment. Show me one result from a comparison which says pass or fail. Okay, so that's one thing. The other thing is that PT is very relevant to testing. Okay, so when chemical labs do their testing or medical labs do their testing, it's very, very important that they're measuring correctly. And the only way that this can be verified on a regular basis, because they probably calibrate or they probably test thousands of samples, right, with the impact being huge. So you want to be able to regularly determine their performance. And this is done through PT. I should also mention that PT providers are different than PT organizers or pilots. So the provider is a company which has the resources to provide this as a service. As a provider, he has the obligation to be able to do the planning. He cannot outsource this. He has to do the evaluation. And when the report is issued, it has to be issued under its name. These are the three basic obligations that the provider has. Okay, of course, confidentiality, impartiality, and so on and so forth. But the ones that absolutely cannot be outsourced, subcontracted, are these three things. So it's not really relevant. So it depends on where we're coming from now. If we're talking about NMIs, PTs are not really relevant, okay? The rules of performing ILCs are the same, but for NMIs, there's no judgment on pass or fail. So if you fail in a ILC as an NMI, you call up your friend at the other NMI and you say, well, I did this wrong and I haven't passed this. Can we set up an ILC? What did I do wrong? Let's set up a supplementary one so I can correct my situation. Yeah. So I think that the choice of the word PT is not correct. Okay, it's not correct based on the meaning of PT. However, let's see now what this might mean. So let's take the Czech Institute, which is world known for its PT services. They're accredited for these services, and they are PT providers. So they organize, they make them, so they do everything, and they're providers, but a provider doesn't have to do everything. There's another provider in Jordan, I can't remember what the name is, that produces reports for labs. And I don't think that they have labs of their own. They have a university that they're working with. I don't know about you, so I'm telling you what I've seen, okay? What I've seen from my accreditation work. So for example, for certain types of measurements, which are not NMI type of work, okay? Usually accreditation bodies accept NMIs or reference labs as what are called designated reference labs. They accept them to be pilots, okay? Um, so if such a lab cannot be found in a particular region, I've seen that these people have done ILCs or PTs using data from a university lab and providing a report. It's a clearly legitimate report. There's no issue with it. But they're just providers. They have an office somewhere and they're just producing the paper. So the provider is responsible for monitoring and overseeing the whole process. Yes. He's responsible for having technical input from a team of experts. Yes. Yeah. Yeah. They're outside. They could be outside of the company which provides the PT. Usually they're a university or an NMI.
Yes, I agree with your question. I have asked an expert in this field for our situation because the laboratory inside the country, the accreditation body, they asked them to participate in BT. And there is nobody, there is no provider inside the country to handle this issue. And they ask us as a task from us to help them for the situation. The experts, as you said, he agreed with you for the situation. He said, you don't have to provide this service as a BT because you are an MI and you are should be accepted from the accreditation body. You can provide this service as check for the laboratory and using following the procedure of BT. Because we are in conflict issue between, because we are the provider and we are the...
Yeah, there's a conflict of interest.
Yes.
That's according to 17043, which is the standard that has the requirements for running proficiency testing schemes. These three activities should not be subcontracted. If they are and they're accepted by the accreditation body, what can I do? I don't know. When the accreditation body will be assessed, if it shows up, then they will get a nonconformity. They're accrediting the labs. Yeah. Okay, this is just one component out of 100 that the lab has to satisfy. Mm-hmm. But we have to clarify now, sorry, if we're talking about NMIs or we're talking about secondary and tertiary labs, what are we talking about? Okay, so we exclude NMIs from this conversation now. Okay, it's one way of looking at things. I don't understand what GulfMed really has to do with all of these things because GulfMed is an association of NMIs. So why is it involved in proficiency testing? And okay, uh, so usually what happens is that I know, for example, in Dubai, there are at least 3 or 4 companies that are providers of proficiency testing, and I'm also confident, I haven't seen them, but I'm confident that they have no measurement capabilities. Um, they probably do have, because you have to have, also you have to be, as a provider, you have to have facilities to store the samples, and you have to have facilities to homogenize the samples. I don't know, but I'm pretty sure that they do not have measurement capabilities. Why? Because there are 2 or 3 organizations worldwide. All of them are in England, in the UK, actually. One deals with samples for food. The other deals with samples from the medical side and biology. So they send you the sample and you send them the results, and they have a website and the things are registered there. So it's very, very easy to, for a testing lab to actually obtain proficiency testing services. Not a calibration lab, though. Huh? For calibration lab, it's more difficult because you have a transfer standard, which you have to make sure that it's stable, and it has to, in order to make sure that it's stable, it has to be measured twice at least. Whereas a sample, okay, you have 10 pieces of a sample, you make your measurements, you send the results, you throw the sample away. That's it. So the situation is very different, and that's why there are not that many PT providers for calibration, by the way. There's one in Dubai also, which is a representative of an Australian company. I found out fairly recently. I can't remember what they're called, PT Australia or something like that, who deal with PT in calibration. And they look like a serious company, at least in Australia. I don't know about Dubai. They're affiliated with the NMI there, so they have technical support from the NMI. The labs from the NMI are used in order to provide the assigned values, and Oh, there are accredited providers. You can be accredited as a provider. You can be accredited as a provider. Based on 17043, not all accreditation bodies offer this service, but many do. But you don't have to be accredited. Slowly, it's starting to move in that direction now. Because the story now is about 20 years old, so everything is moving towards accreditation. And medical measurements and testing and pesticides and water and food is very, very important.
I think PT it's voluntary, but ILC it's mandatory.
You're sorry.
You didn't hear me?
No, one more time. Voluntary.
They
it's not voluntary.
Some of the provider they are running some fancy testing, and who want to participate, they participate. ILC it's mandatory because any national measurement lab, national measurement, I should have the laboratory component publish the CMC. PT it's
What's the difference between a CMC published in the BIPM and the CMC published in an accreditation body? There's no difference.
In general, both of them voluntary.
It depends on the accreditation body.
It's come if there is requirement by certain.
So, for example, the former DAC, AAC now, has a requirement that you have to fulfill within one accreditation cycle, you have to cover all of the major disciplines in your scope.
Yes.
Even though there's a tendency nowadays to move away from that, and because now risk is a big deal, so most accreditation bodies want you to formulate a plan which minimizes risk, so they don't have, again, they're trying to move away from absolute numbers and saying that, well, you should plan so that risk is minimized. But pretty much within one cycle, you have to cover sample from your scope.
ILC. It's to masters. Example, in comparison, it's related to gauge flux as a reference. In BT, there is no BT.
No. It has nothing to do with the level of accuracy necessary. Okay? Because in the secondary level, secondary labs, they don't have gauge block interferometers to do their. So you have a micrometer which moves around, and they calibrate that. So it doesn't matter. The difference is that PT is conformity assessment through ILC. Okay? So you do an ILC so you can be assessed as to your performance, your capability, your competence. Okay? That doesn't come into play when you're doing an ILC as an NMI or something else. There, you just do your measurements. You do well, you don't do well, there's no judgment. Okay?
That we should can provide also BT gauge flux.
Well, the PT provision is a business. So if you see that there's a market for it, by all means. But I don't think that there are too many labs out there that are doing, gauge block calibrations. So maybe you can provide PT for calipers or rulers or I don't know, something like that. Yeah.
like this because I find I'm asking why we agree. What that he accurate
Mhm.
issue just the artifact
Mhm.
and the final
Yeah.
the implementation.
No, 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 that's not an issue between the PT. So I told you what the issue is. The issue is that in one case, when you have a PT, you at the end, you have to make a judgment. Whereas for an ILC, you don't have to. That's the difference.
I want it still.
That's the judgment. Okay, but then it's a PT. It's not an ILC. It's PT is judgment on the performance through an ILC. Is that clear? So you have to perform an ILC, and at the end, you have to produce a report which says pass or fail. An ILC is just the measurements, and you produce a report which says that these measurements were done and these are the results. That's the difference. No, that's not what I'm saying. What I'm saying is that in addition to the ILC report, in a PT report, you have a section which describes why a particular participant satisfies or does not satisfy the requirements set. That's the additional thing of the PT with respect to the ILC. But you use an ILC to do this. Well, okay, it depends. We don't want to get into the details now of all of these things. But with regard to the uncertainty, I have to clarify that um, it's not a good idea to tell them which components they should be actually including, okay? You should let them do it by themselves. They should give you their uncertainty budget, so you should tell them to give you the uncertainty components so you can judge whether they're in the right track or not. You should, in the protocol, you should have this request. And so now I lost the other thing that I wanted to say. Anyway, it'll come back probably. If someone wants to play the role of a provider, which again is a business, as I said, yeah, it's good. Mm, well, that's correct, but it's not. What's the word? It's not the only way. Okay, so in an ILC, for example, if we're talking about a key comparison, you have a reference value there also. It's just the way that the reference value is calculated is a little bit different. So in an ILC, the reference value is typically calculated from consensus, whereas in a PT, typically it's calculated from a reference lab. Typically, it doesn't mean that that's the only way. It could be done from consensus. or partial consensus. So it depends on what the situation is. So that's the thing, that the provider has to have access to the technical expertise to decide on issues of this sort. Yeah, ILC is the tool for PT. Yeah. Again, the purpose of the PT is a conformity assessment, so pass or fail. The purpose of a ILC is to see what, I mean, it's a exploratory, let's say, tool. Yeah. 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 So you use an ILC to do a PT. That's it. Okay. Um, so maybe we should take a break. What do you think, Omar? Do we need a break? I need a break for sure. I'm going to fall down. So maybe what, 20 minutes or something?